Welcome students to lesson 50. This is Algebra 2. We're going to talk about quadratic equations and completing the square. We already know what a quadratic equation is. We know that we have, if we have x squared plus x minus 2 equals 0, we know that this is a quadratic equation. A quadratic equation is simply having two of the same variable terms. One of them is squared and one of them is to the 1 degree, and then we have a constant. And then that is in an equation format. It could look like this. It could look like this. As long as you only have those three components, or you have numbers over here that you could combine with these and get those three components. I mean, you could have 2x squared, and then you have x squared here, and then you have, let's say you have plus 2x minus 4, and you have plus x minus 2. All right. This is still a quadratic equation because we can take these things and subtract them or combine them. We're doing the same thing to both sides, right? That cancels, that cancels, that cancels. So we're left with 0 over here. This is negative 2, this is positive x, and this leaves x squared. So it's the same thing. It's a quadratic equation, but it's all the same variable, and you only have to the x degree of 2, 1, and 0. All right? So that is a quadratic equation. For the most part, when we have these quadratic equations, we can factor, especially when we set them to 0. We can just factor them into binomials, and we get like x plus 2, x minus 2, or minus 1. Right, so when positive 2x and negative 1x combined, we're left with a positive 1x behind. So we can factor that, and then when they're different, like this, we can set them equal to 0, because we know that one of these has got to be 0. So there's potential here. And just looking at that, we can see that x is going to be equal to either negative 2 or positive 1. Right, and that would be our solution for that. What if we can't do that? What if we can't factor the quadratic equation? What if it looks something like this? Let's say this is our problem. X squared plus 4x minus 2 equals 0. We can't factor that. We can try. We can get x, and we can get x, and we can get that negative 2. To get negative 2, we need a positive 2, negative 1. Well, that doesn't give us 4x. That gives us 1x. And if we did negative 2, positive 1, well, that'd give us a negative 1x. So we can't factor this. So what do? How do we solve this problem? We solve it by doing a process called completing the square. All right, so we have to complete the square. And that process requires that we reach back into the rules of equations and say, whatever we do to one side, we have to do to the other side. So first and foremost, we're going to set it up so where we have all the x's on one side. So x squared plus 4x. If we add 2 to both sides, we get 2 over here. So now we have all of our variables x on one side, and we only have this one constant here. We need to turn this into something that we can factor, but we still have to keep the equation balanced. So the way we do that is we take this term that has x to the 1, and we are going to take 4, it's a positive 4, that's important, divide it by 2, and then we're going to square it, and that is going to equal what we're going to add to both sides. So in this case, 4 divided by 2 is 2. 2 squared is 4. So we're going to say x squared plus 4x plus 4. But we're going to add that to both sides. When we add 4 here, it'll be 6. Now we have a perfect square. So we can actually look at this and say, okay, this is equal to x plus 2 squared. It is a perfect square. So we can do that. And that equals 6. How do we get rid of this? We do the radical symbol, right? So this cancels this. So we have x plus 2 equals plus or minus the square root of 6. We want to get x all by itself because we want to solve for x. So we subtract 2 from both sides and we get negative 2 plus or minus the square root of 6, and that is our answer. And that is how you complete the square. We take the middle term and we divide by 2 and then square it. Okay. Then we add it to both sides. Factor to a perfect square. And then we're going to unsquare and solve for x, or whatever the variable is. All right, those are your steps, 4 steps. We take the middle term, divide it by 2 and square it, add that to both sides, factor to form the perfect square, unsquare it, and then solve for x. All right, so let's do 50.1. Let me clear the page. 50.1. And we have x squared plus 6x minus 4 equals 0. So let's look at that. We cannot factor that because negative 2 and positive 2, which are the only factors that would give us a negative 4, they would combine to be 0. This is not a perfect square, so we need to make it one. So we're going to set this, the values of x, apart by adding 4 to both sides. Okay, now we're going to take our middle term of 6 and we are going to divide it by 2 and then square it. 6 divided by 2 is 3. 3 squared is 9. So x squared plus 6x plus 9. But whatever we do to this side, we have to do over here. So 4 plus 9 is 13. Okay. So now we can unsquare this, or we can factor this. And we know it's a perfect square because we did it on purpose. We know that this is going to be x plus 3 because x times x is x squared. X times 3 times x would be 3x, and x times 3 would be 6x. This is squared as 13. Okay, and if you want to double check, you just do it over here. This gives us x squared. This gives us 3x. That gives us 3x. And this gives us 9, right? x squared plus 6x plus 9. That's what we started with. So we know this is a perfect square. We did it just right. So now we unsquare it with a radical, right? That cancels that. So x plus 3 is equal to plus or minus the square root of 13. We cannot unsquare anything out of the 13. It's a prime number. But we do need to move this 3 over so x can be by itself. So we're going to say x equals negative 3 plus or minus the square root of 13. And that is the answer. All right, you see how easy those are? It's just about remembering the steps. You have to turn it into a perfect square on this side by adding whatever number you need to add, but you do have to add it to this side as well because you got to keep the equation balanced. All right, let's do 50.2. It says 2x plus x squared minus 5 equals 0. All right, first things first, let's rearrange it. Put it in the right order. There are no factors of negative 5 that would give us 2x. Negative 5 and positive 1 would be a negative 4. Positive 5 and negative 1 would be a positive 4. So we can't get this. So we have to turn that into a perfect square manually by adding 5 to both sides just to get it out of the way. Now we have to take this, divide it by 2, and then square it. All right, 2 divided by 2 is 1. 1 times 1 is 1. So x squared plus 2x plus 1, and then we have to add that to 5, so 5 plus 1 is 6. All right, now we can square this, and here is a hint for you. Whatever 2 divided by 2 is, whatever the middle term before you square it, that's going to be what you put here. So x plus 1, right? That equals 6. We're going to unsquare this side. That cancels. So x plus 1 equals plus or minus the square root of 6. Subtract 1 from both sides. Negative 1 plus or minus the square root of 6. That's your answer. All right, I'm going to let you guys try the next one on your own. Let's clear the page. We have x squared so pause, work that one by yourself, and then press play and see if we got the same answer. All right, if you got x equals 5 over 2 plus or minus the square root of 5 over 2, good job. If you went further and said that you had 5 plus or minus the square root of 5 all over 2, that's correct as well. This is where your book stops right now. It doesn't take it this far, but I could see how some of you would apply what we've learned in the past about common denominators to putting it together, and this is also correct. So either one of those is fine. But the way we got that was we started up here and we had to put it in the proper order. Well, since we knew it wasn't going to be a perfect square, we left the negative 5 over here and we just moved over the 5x. So we subtracted 5x from both sides and it gave us this. So we took this middle term, this x to the 1 term, I'm sorry, those should all be squared. We took this middle term and we divided it by 2, and then we squared it, and we got 25 over 4. And we added 25 over 4 to both sides. So whenever we did it to this side, I converted negative 5 into negative 20 over 4 because negative 5 times 4 would be negative 20. But I wanted to go ahead and give them the common denominator so that I could go ahead and do that math more readily. And then when I factored my quadratic equation over here, I was able to say x minus 5 over 2, which again, negative 5 over 2, that is what we had before we squared it. So that is what goes into your parenthesis with x. So that's, an easy way to remember how to factor that. You don't actually have to figure it out. It's already given to you. So when we combined these, we had 5 over 4. We unsquared everything, which left us with x minus 5 over 2 plus or minus the square root of 5 over 4. So what we did to this right here was we said square root of 5 over square root of 4. This became a 2 because we can unsquare a 4 pretty easily. 2 times 2 is 4. And that left us with square root of 5 over 2. When we took this from this side to solve for x, we added it to both sides. That became x equals 5 over 2 plus or minus the square root of 5 over 2. Then we put it all over the same denominator because it was already the same denominator. And that was the answer for x. So either one of these is correct. I'll check them both right. But that is how we complete the square on something like this that ends up looking like a fraction. Don't go ahead and divide this. Just leave it a fraction. Everything doesn't have to turn into a decimal. In fact, in algebra, most of the time we don't like decimals. We usually want to keep it a fraction. So that's all I have for lesson 50. Remember the steps to completing the square. If you need to, rewind this video and write the steps down. Make sure you look through these practice problems, practice them again, write them on a separate sheet of paper, and see if you can do it again and then compare it to the video. That's always a thing that you can do is pause the video, watch it a second time, pause it when you get to the problem, solve it, and then press play and make sure you got the same answer. You can do this as many times as you need to until you get the same answer. All right? And that's all I have for lesson 50. I will see you in lesson 51.